Okay, so the meeting is being recorded from this moment on. Let me start with welcoming everyone. So welcome everyone to the webinar entitled From Experimentation to Deployment, Aligning AI Testing Services with Industry Needs. My name is George A. Srintzis. I'm a professor at the University of Piraeus in Greece, and the other speakers and panelists of this webinar in some random order: Stratis Karanachos from European Dynamics, Elissaios Sarmas from NTUA, Johanna Forberg from the Technical University of Denmark, Stefan Chalner from Enlight AI, and Evangelos Karakolis from NTUA. Well, thank you everyone for your participation in this webinar, and I'm sure there will be very interesting and very enlightening discussions throughout this webinar. Let me outline what we are going to do in the next hour and a half. We have two sessions. In the first sessions, there will be presentations of three projects, namely AI Effect by Johanna Forberg, EnergyGuard by Vangelis Karakolis, and EnerTEF by Elissaios Sarmas. And in the second session, there will be a roundtable discussion on issues that relate to these projects and issues that relate to the use of artificial intelligence in the energy sector. And the roundtable panel will be enhanced by Stratis Kanarachos from European Dynamics and Vangelis Karakolis from EnergyGuard and Stefan Chalner from Enlight AI. If you allow me to say just a few words for each participant of this webinar, Professor Johanna Forberg is an assistant professor in the Department of Wind and Energy Systems at the Technical University of Denmark. Evangelos Karakolis is a senior researcher and software engineer, specializing in various aspects of artificial intelligence technologies and big data technologies. He's affiliated with the National Technical University of Athens. Elissaios Sarmas is a research associate in the School of Electrical and Computer Engineering of NTUA, and his area of research and expertise includes AI, data science, and optimization, with a focus on issues in the energy sector. Stratis Karanachos has a 25-year experience in senior roles across academia and consultancy, and he specializes in research and innovation management and in the digital transformation, and he's a worldwide recognized researcher in his areas. Stefan Chalner is a senior machine learning engineer at Enlight AI, who also specializes in applications of AI in the power sector. And finally, I'm a professor in the Department of Informatics. I served as head of the department. I'm currently serving as a member of the Administrators Board of the University of Piraeus. My research works have appeared in books or international journals and conference proceedings, and I have co-founded the Information Intelligence Systems and Applications Conference Series, which is technically sponsored by the IEEE. I have also co-founded two series published by Springer, namely the Learning and Analytics in Intelligent Systems series and the Artificial Intelligence Empowered Software and Systems Engineering series. I served as the chief editor of the Intelligent Decision Technology journals for a period of 8 years. And I'm currently an associate editor of engineering applications of artificial intelligence and knowledge-based systems, both published by Elsevier, as well as an academic editor for electronics published by MDPI. And with this said, I think we should move to the presentation of the three projects, starting with the presentation of, one moment, please, some problem here. Starting with the presentation of AI effect, and the presenter will be Professor Johanna Forberg. Professor, please take the floor.
Thank you very much for the kind introduction. So I think everything should be set up. It's my pleasure to introduce the project to all of you today, and then also to show you what are the testing capabilities that we're developing as part of the project. To give you a bit of background and motivation that we had generally for the project is that we want to support utilities and also other stakeholders in the energy domain, mainly the power sector, but also we're looking at multi-energy systems to test new solutions that can actually tackle some of the new challenges that we see. And the key here is that we want to help around the security, transparency, and validation to meet industry needs and to build new standards for testing of AI tools. So I'm going to be speaking on two dimensions here, where one is always the testing capabilities that we're building, which are general for different AI tools or applications, and then also the demonstrators that we're developing to show how such testing can be done. As part of the project, we have 4 nodes across Europe, where each of them demonstrates certain testing capabilities that are then coupled with different applications. So for example, the Danish node, we're focusing on district heating and sector coupling. So here it's really to use AI tools to optimize the operation of such systems and also the real-time control. And we want to build an end-to-end testing environment that also involves real-world testing. The Dutch node application evolves around transmission system congestion management, where they want to focus on developing predictive models for congestion management and dynamic grid control that essentially can support operators in the control room. The Portuguese node is all around energy efficiency, energy communities, and data spaces. So there's really to improve energy efficiency in buildings and industries, and testing those solutions for various types of buildings and industrial settings. And the German node's applications focus around distributed energy resource integration into distribution systems to enhance the resilience and flexibility of the energy grid. So these are the different use cases that we have for the AI tools that we want to test. And in the rest of the presentation, I'm going to walk you through what are these testing capabilities that we're building as part of the project. So generally speaking, what do our AI fact services offer, or what we're aiming to offer and what we're currently building? We want to support industry and AI tool development from data preparation to real-time deployment and monitoring in real-time operations. That is by providing access and secure access to relevant data, provide benchmarking, provide validation algorithms, and then also support with moving from simulation-based testing to lab-based testing to real-world scenarios. So we are, like I said, showcasing all of those testing capabilities at our different nodes. And the goal generally is that we have this end-to-end support from data provision throughout the whole pipeline to real-world environments. For that, we have actually harmonized the services that we want to offer across all of our 4 nodes into some specific categories that I have recategorized here. So we have 3 different services that are around data provision, and this slide is just an overview. I'm going to walk you through the services in more detail in just a moment. Then we have 2 services that specifically focus on enhancing the trustworthiness and providing performance guarantees. Then we have some general testing and benchmarking services, which are simulation-based or lab-based. And then we also have human-in-the-loop services, where one is human-AI interaction testing. And then we also will have living lab-based testing in different stages of the project. So now I'm going to walk you through those in a bit more detail. The data provision services, so I guess it's quite clear what data provision is going to be. So here the goal is that we provide access to relevant energy data in the required formats. This can be historical real-time data for training, testing, and validation, and it could be data sets, APIs, or data streams that you could get direct access through our platform. The second service here is the knowledge store, which basically means that we will provide or augment a data set with additional relevant features that could improve the learning of AI tools. For example, augment and add weather data, other contextual or domain-specific variables, and these are then specific to the actual test case and application of the AI tool. And here the goal is to have an improved model quality through better feature sets. And then our last service for data provision is data synthesization service, where we generate synthetic data for AI development and testing. This is currently still developed in one of our nodes, and there it's mainly for creating varied grid or operational scenarios from metadata or representative data. So it's really more about grid data and providing synthetic grid data. This is very useful when we have privacy concerns or confidentiality that prevent us from sharing actual data. Then it can be synthesized or aggregated. So these are the types of data that we will provide access through the AI.grids project. So it's from real data to enriching features, and then also expanded data for learning. The next service that I want to write you through is one of our verification services, and that's the explainability analysis. And I'm going to take a moment longer to explain this because I'm not sure how much of you are familiar with explainability. This service is based on Shapley values. I'm going to showcase here in a moment what that means. But what the service can do is that it can actually explain global model behavior, but it can also explain individual decisions to support operational trust. And what that means in an application, I'm going to show you with a very simple example that's not really power system related, but that's going to show what you can get out of the service. So for example, and of course this is not how we should use AI, but maybe an AI tool decided that John cannot get a loan, and then John of course has the question, why can I get a loan? Like, what's the factor? And then with this Shapley analysis, or with Shapley values, we can actually calculate which features had which contribution in that decision. So maybe there was a base rate that anyway says that on average, any person has a 20% chance of not being able to repay a loan. So that was a first factor in that decision. But then there was maybe a second factor, realizing that John was only 20 years old, so it didn't have much credibility, which then pushed that to 50% chance of him not being able to pay the loan. But then John is also a crypto trader, which for the bank makes him a not very trusted asset. So that makes his chance of paying back the loan not paying back the loan even higher to 90%. But at the other end, maybe also John has quite a bit of savings, which then reduce the probability that he cannot pay back the loan to 60%. So that is how maybe the AI tool came up with this 60% chance that he will have problems paying his loan, and then the ultimate decision that he would not be granted a loan. So with this is basically a demonstration how the Shapley values work. So for a specific prediction, we can get these proportions of how much did each of the feature, how much did that impact the output? And we can apply that to all sorts of AI tools and cases. So we can always get this analysis on how important was each feature in the prediction. We have already developed the service and we have already developed this as a toolbox. So if you're interested in trying this out, this is actually available as an open source GitHub, and it's working for any type of AI tool. It's model agnostic. So if you would want to try to explain your AI tools and use our toolbox, you could already do so now. The second more detailed service that I also want to explain a bit further is about verification, because then I'm also not sure how familiar you are with this. And the question here is, why do we need verification and what is verification? So I guess we all know that machine learning is very fast, but generally there's no guarantees on the performance. So when we look at these two different testings, we can see that here on the left-hand side, the AI tool was tested on the grid where the performance looks somewhat good. But then on a right side, it was tested with random points. And we can see that the result that we're getting from this testing is very different. So the question is, how should we actually test the output for continuous ranges to ensure that we properly test the behavior of our AI tools? The second point is that any testing that we do, the accuracy is purely statistical. So, I mean, it's the flow of the averages. So you can see here, any statistician drowns in a river that is 3 feet deep on average because of the average height. So the question here is, how can we get from these average testing to actual guarantees? And that is also what verification can provide to us. And then the third reason that we need verification, and I'm guessing also that most of you are aware of this, is that small perturbations of an input can actually lead to false predictions. So for example, in image recognition, if we're having this pig as a first image and we're adding a small noise, then all of a sudden the AI tool will not recognize it anymore, although all of us will be able to recognize it. So of course, this is a problem, and we actually need to identify such adversarial examples in our AI tools. And verification is a tool that can actually ensure that the trained model does not violate some verifiable property. And the mathematics that are behind this are quite complex, so I'm not going to show you those, but just generally speaking, for every input that you have in your set of inputs, so we have an input region, we always want the model's prediction to satisfy some given constraints and not violate them. And then we can verify that for certain regions, and we can also verify which regions these constraints are not being met. So for example, if we think in terms of power systems, if we think that we have an AI tool that is predicting us the optimal power flow output, we could have a verification on the optimal output, like how much will be the distance, the maximum distance from our AI tool output to the actual optimal point, or how much will we have a worst case violation of our line flow constraints. And that is something that verification can provide us. And the key difference here really is that we present the input region, we don't have to sample it, but that we really can show it as a continuous range. And by that, we are overcoming some of these flaws in testing that I discussed before. So in summary, the service provides rigorous performance guarantees for such trained AI tools. This one, it's not model agnostic and it doesn't work for all tools. However, we have now been able to develop it for optimization problems, for linear ones, and also for some nonlinear problems. And we can assess worst case constraint violations, abnormal inputs, and distance to optimality. And this can be used, for example, before going to simulation or lab-based testing to identify the critical operating points of your AI tool and show you where you maybe want to enhance it during training, or actually where you want to test it in a real world environment. Also, this verification engine is already available on the GitHub. So for these optimization problems, it can already be used on GitHub. Then the last set of our services are then the testing services. So here we have a benchmarking service that compares AI models against baseline or state-of-the-art methods and provides standardized metrics and test environments. So this is generally to show more empirically how good your AI tool is, and benchmarking it against other solutions. Then we have simulation-based testing that tests AI tools in realistic but controlled simulation environments to explore operating scenarios and edge cases. And in our case in Denmark, like I said, we're using verification to identify where such testing would need to be done. Then we also offer lab-based testing in some of our nodes where we actually go to physical lab infrastructure and test the AI tools with real hardware and real-time control interactions before then it would be deployed in the real world. In two of our nodes, we also have living lab testing, which in both nodes works a bit differently. But here the idea is that we test the AI tool either using real-world data or to actually have a real-world closed-loop environment where we can actually also change control settings. So this is a step towards testing in real-world scenarios. And then the last one is the human AI interaction testing, which is mainly done by the Dutch node who are doing these decision support tools for operators in the control room. And here the idea is to evaluate the interaction between AI tools and the human operator to assess usability and the decision support. So these are then the last set of services that we have, which go from a control testing environment with the benchmarking and simulation-based testing to real-world deployment in our lab-based testings and human AI interaction testing. All of these services are going to be showcased in almost all of our nodes. So each of the nodes is going to use these services to test the AI tools for the different applications that I talked about initially. And here's an overview of which node is going to demonstrate which of the services with their applications. As a last step, I want to guide you through one of those example pipelines, and because I'm part of the Danish node, I'm going to use that as the example to walk you through. So one of the cases that we have, which is then the application of the AI tool, is that we want to have an AI tool that controls the temperature and flow velocity in a district heating plant. And then DTU Wind is going to provide those TEF services through the AI Effect platform. And we are backing up our services by actually having data from some of our partners, which are then grid operators in Denmark that provide us with real-world data that we can use to provide the services. And in the first step, we're going to provide this explainability analysis to provide insights into AI learning and explain the outcomes of such AI tools. In the second step, we're going to have the mathematical verification where we provide these performance guarantees on which operating regimes this controller is going to work well and where we're going to have these worst case violations. In the next step, we're then testing that controller in a lab-based environment, which is what we're currently actually setting up. And then the last step will be that we will actually have living lab testing where we benchmark the controller against real-world control results and set points and compare those against one another. That was it from my end, introducing our services through the AI Effect project. So thanks a lot for the attention and dialing in. Here's also an overview of our partners. Yeah, again, thanks for having me. And I guess I'm giving it back to Yorgos.
Thank you very much, Johanna. Am I pronouncing your name
perfectly.
correctly?
Yes,
So,
Johanna.
okay.
It's great.
It's from the little German that I learned in my youth. Very little German. Thank you very much for the very interesting presentation. Perhaps we should move to the presentation of the next project, and we'll have time after the presentation of the three projects to further discuss this one and other issues that relate to this webinar. So, Vangeli, will you please go ahead and present EnergyGuard?
Yes, sure. Thank you,
Okay,
Georgos. And thank you,
great.
Joanna,
Thank
for
you.
the great presentation. Hello, everyone. I'm Vangelis Karakolis, Senior Researcher and Project Manager at ICCS. We are coordinating EnergyGuard TEF. A few words, sorry, just a minute, please. A few words on EnergyGuard. It is a European-funded project with a duration of 3 years and a budget of around 6 million euros. It has started 1.5 years ago, and we are halfway through its completion. Our consortium includes 16 beneficiary organizations, including 6 SMEs from 9 different member states. But what actually EnergyGuard does? So the main motivation that guided this project was the realization that 60% of research-grade AI never reaches the industry in the energy sector. And this is because the energy sector and especially the grid is complex, critical, and high risk. So you can't really experiment on a live grid or a plant. And yeah, there are several pain points, including limited data availability, limited expertise, go-to-market validation costs, and complexity of AI regulations. So EnergyGuard is here to help AI innovators, including startups and SMEs, to test new AI technologies, solutions, components, while addressing all these challenges. So innovators can develop solutions, analyze extreme scenarios, and validate them on both performance, trustworthiness, security, and finally meet regulatory requirements before deployment in production. And since AI for energy often needs large-scale compute, we provide high-performance computing through Meluxina AI. So EnergyGuard, in a nutshell, is here to help AI innovators in the energy sector produce trustworthy AI products faster and with a lower risk. Hence, the main objectives are bringing an open green testing and experimentation facility for AI applications backed by high-performance computers, deliver a range of tools and services to enable AI innovators validate their applications in the energy sector, and provide an environment for assessing legal compliance, trustworthiness, and offer quality assurance for their solutions. And, of course, create a publicly disclosed database of AI risks specifically tailored to the energy sector. The project covers the full energy value chain from transmission system operators to distribution system operators, end users, energy communities, and buildings. And this coverage ensures that our solutions, that AI solutions for the energy sector can be tested in realistic conditions before launching as a product to the market. And here are our facilities. EnergyGuard brings 5 EU large-scale testing and experimentation facilities covering the transmission system, microgrids, hydrogen, residential buildings, and renewable energy communities. Each facility brings infrastructure, data, and digital twins. And of course, the system is supported by Meluxina AI, which is the core of Luxembourg AI Factory. Moving on to the overall approach, the EnergyGuard TEF nodes enrich the platform with data and digital twins. On top of that, there is a secure AI development sandbox and a trustworthy AI assessment environment supported by end-to-end security and useful AI resources. And all of this will help client companies move from lab to market faster using EnergyGuard solutions and tools and unlocking new opportunities leading to overall wider market introduction and expansion. An honorable mention to the trustworthiness assessment. I wanted to focus here actually because this is the final checkpoint before an AI system goes into production and also a unique selling point of EnergyGuard. So the user here verifies compliance with the AI Act, audits the code for security and vulnerabilities, and evaluates trust indicators like transparency, explainability, robustness, fairness. And the process ends with a trustworthiness scoring mechanism and clear recommendation for improvements. And from the client's perspective, the EnergyGuard user journey is clear. The user applies for access, specifying their needs. And once approved, they enter the secure sandbox. There they can work with real-world data and models and monitor, evaluate, and refine their solutions. Then the solution undergoes holistic validation and trustworthiness assessment. And finally, if successful, the product can launch. It can be published in EU marketplaces like DOM and AI on demand. And I want now to present a real use case from the platform with some screenshot in order to make EnergyGuard's functionalities more clear and more hands-on to everyone. So the user scenario, a real-world example is a user reaches the EnergyGuard platform. The user is an AI developer that has implemented EFI DSS, which is an AI service that provides energy efficiency investments decision support. It is an AI-driven tool that predicts energy efficiency gains of renovation actions, and it is based on a physics-informed deep neural network. So the challenge: how to turn this service, EFI DSS, into a market-ready AI energy solution. The user needs to know if his models are ready for production, if the data he has used is enough, and how trustworthy it is, the service. He needs harmonized building data to improve the model's performance, to validate against real-world conditions, to expand its coverage across different building types. He needs also computational infrastructures to train a large-scale model, to add other demanding functionalities such as large language models, and probably more. And of course, he needs regulatory trust. So he needs to officially benchmark for his models and services for AI trustworthiness and the alignment with EU regulations. EnergyGuard TEF provides an environment to test, validate, and improve this service because it provides real building and energy datasets and the building's digital twin, along with high-performance computational infrastructure, AI trustworthiness benchmarks, and compliance assessment. So here is the landing page for EnergyGuard after logging in, of course. So the user can select from different assets such as datasets, AI models and services, digital twins and facilities, his past projects, trustworthiness assessment tools, and high-performance computing. Let's start with the datasets. Here is the page with available datasets. And of course, he can filter by the category of the datasets, the use cases they cover. So the user selects building and energy efficiency datasets. Currently, we have 18 such datasets. So he selects the university campus energy consumption dataset. He can view brief information and metadata about this dataset. He can preview the actual data, he can download, or he can use the data directly in the platform through a Jupyter Hub interface through the functionality Run Dataset. Furthermore, there are the digital twins. Here is the page for digital twins and the different facilities of EnergyGuard. So he selects the Riga's multi-apartment residential buildings digital twin, and he can view a general overview of this digital twin. And of course, he can access the service through the button Open Digital Twin. So here is an interactive map where the user can view real buildings in Riga city and filter by the energy class. So here we see in a specific region all buildings of classes F and C, and along with some statistics. Of course, there are further functionalities with that. But I'm trying to give a really generic overview of what someone can do. So I will move on. The user can request for high performance computing. Here is the page for HPC provisioning. Of course, in the beginning, users by default don't have access to HPC. They have to request access, and there is a process for that. However, there is a Jupyter Hub interface that anyone can access that provides some computational capabilities. So a user can very fast run model training and evaluation. And if he needs more, he can request for HPC. Here is an instance of the Jupyter Hub interface. The user can directly send datasets from the platform to this interface or upload their own datasets and run Python code, train models, and maybe also evaluate and deploy. Last but not least, we have the trustworthiness benchmarks and compliance tests. The user from the landing page can select the trustworthiness and compliance assessment, and he can select from several tools. For instance, here we have code analysis. There are also tools regarding AI compliance, security, trustworthiness, etc. Very briefly, in the code analysis section, the user is requested to upload his code base either in a zip file or provide a GitHub repository. And then the system inspects the entire code base and provides reports with the issues and several improvements in order to enhance the code quality of the project. Furthermore, we have another example is robustness evaluation. So here we investigate adversarial robustness. Going back to EFI DSS service, the developer has trained their models in EnergyGuard and logged their performance in MLflow. So the system pulls building data from a central database. Of course, these databases are prone to contain rounding errors, outdated hand-estimated values. The model should be exceptionally resilient to input fluctuations and probably manipulation. The user opens the trustworthiness sidebar we showed in the beginning, clicks on the robustness tool, and creates a config file specifying things like the model source and backend, the task type. For instance, here we have regression, the dataset path and target column, and the attack types and sample size. An evaluation for adversarial attacks is run, and the user is redirected to the report page. Here are parts of the report page. The system shows, the system shows the error. For instance, we have here RMSC under the baseline error and the error under an adversarial attack where we manipulate input data. Furthermore, the user can view feature perturbation graph to identify which features are the most targeted. For instance, here, there are several important features like the total floor area, the apartments, and the useful area for this specific application and model that are the most sensitive inputs for adversarial attacks. And of course, the system suggests some improvements in order to harden the systems in terms of adversarial attacks. This is just a short glimpse of EnergyGuard testing platform. Here in the links we provide, you can view more, and of course use also the platform. We just released the alpha version of the platform. So please feel free to experiment with it and let us know your experience. Thank you very much.
Thank you, Vangeli, for the presentation. Again, Carly is collecting questions that we may discuss in the second session of this webinar. I think we should move to the presentation of the third project, EnerTEF, by Elissaios Sarmas. Elissaios, will you please go ahead and present it?
Sure. First of all, thank you, Prof. Chrysis, for the introduction, and I would like also to thank all the other members of our advisory board for being here. For example, Tudor here from Romania and some other colleagues, also some external colleagues. Thank you all for devoting these 2 hours to hear about our projects. I will start by sharing my screen, and please let me know if you can see it.
Yes, we can see it very well.
Okay, great. I was envisioning giving a 15-minute presentation as required for the project, but then what I saw is that we had already presented several things during our previous advisory board and workshop meetings that we had. So I am thinking about giving a 5-minute presentation and then navigating you through our online and living assets. So let me do very quickly this introduction about our project and then proceed with a live demonstration that will open the floor for some nice discussions. For the ones that hear for the first time about our project, EnerTEF is a European project, a Horizon 1, a sister project of the previous 2, and thank you very much to our colleagues from DTU and ICCS from the presentations. This project has 25 participants. The coordinator is the National Technical University of Athens and more specifically our laboratory, Energy Policy Unit. We have partners from 10 different countries, and the project is currently in the middle. So we have finished with our first 18 months, and we have another 18 months to finalize our efforts. Here you can see our website, enertef.eu. What we try to do is to bridge the gap between startups and big energy utilities, TSOs, DSOs, industries, and how can we enable that? We would like to enable it by creating a living space. We call it the EnerTEF Portal, which will allow end users, AI service developers, and even asset owners and administrators of different energy assets to come together. So in the left of this slide, you can see a very complex architectural UML diagram that will be then summarized into a very nice user interface that I would like to show you. What we'll enable via this portal is to give the opportunity to novel SMEs, to startups, and to other stakeholders such as industry, academia, and so on, to develop AI-based services specified across the whole federation of our portal. So we have created a total of 65 AI services. You can see a snapshot of the catalog here, which is distributed across 5 nodes, composed of physical, digital resources, and even HPC resources and regulatory sandboxes, as well as 3 different satellites. And you can see that we span across all the different use cases: buildings, TSOs, renewables, e-mobility, DSOs, hydrogen, district heating networks, and even industrial flexibility with different services. You can explore our catalog in the link that you can see in the right bottom part of the slide. The catalog covers the energy system end-to-end, as I said. So we have cases around forecasting, like load forecasting, PV, wind, hydro, and other assets. We have cases around optimization and decision support, like, for example, flexibility optimization, scheduling of flexible loads, and self-consumption. We have cases around anomaly detection in different assets and predictive maintenance. And we also aim to cover more difficult tasks such as automation and control systems in buildings, in substation level, and even power system automations like optimal power flow and grid stability assessment exercises. As it was the case in the previous projects, the same applies with EnerTEF. We don't aim just to drive AI solutions, but we aim to create trusted solutions. So trust is treated not just as an afterthought, but as an evaluation layer. So we have developed a nice methodology which aims to assess how trustworthy its service is. So it aims to cover different pillars of trustworthiness, such as explainability, robustness, uncertainty, fairness, drift, and sustainability, and to create the overall score per service. All of this would not be doable without taking into account the European Union's AI Act and the GDPR alignment, which has been translated into a very easily repeatable workflow. So all the data that we take are classified according to its risk. They are checked for GDPR, they are prepared for evidence, they are validated in a sandbox environment, and then they are made active for deployment. Here you can see another complex diagram. I do not expect in just a blink of an eye to understand what we have tried to do. It's such a complex architecture which is composed by an AI experiment workbench, an orchestrator for high-performance computing resources, the different decentralized TEF node ecosystems, which are composed of physical, digital assets, digital twins, and even different datasets, as well as for different data space connectors in its decentralized node, which are brought together via an interoperability middleware, and the entrance on all of this infrastructure is allowed by a single sign-on interface with a federated IAM. And here you can see a first snapshot of the marketplace. I will not stick to this slide a lot because I will show to you our beta version in a moment. Here is the governed data sharing. So we have created with the support of our technical coordinator, European Dynamics, and some key other partners like INESC, an energy data space connector interface tailored specifically for EnerTEF, so that we can enable data sovereignty and well-structured bidirectional exchange. I'm very happy to see that we are also homogeneous and interoperable with the other projects. We had some meetings last week to bind this data space middleware with EnergyGuard as well. So this is a quite good step towards interoperability in a European level. And here you can see our inventory of facilities, data environments. So we have different assets like hydropower plants, PV plants, wind farms, data from grid and substation assets, hydrogen, and even buildings. And here is just a snapshot of one of the assets. So from municipal building data, we aim to digitalize everything and to provide operational energy intelligence. So here you can see our energy portal for the city of Athens, which is a partner in the project. And we have managed to make it the first city in the European level to have both the billing information, but also real-time data accessible for everyone. Here we present some AI services for renewable asset operation and forecasting. You can see forecasting for hydro, for PV, wind, and even some good tools like the Oasis tool for explainability and for tailored LLM-based monitoring. Here we present some services, open source microservices, actually for distribution system operators. This is the Sonio platform, which is available and has been extended in the course of the project in order to enable some grid operation services in the medium and low voltage. And here you can see some of the services that have been developed already. So from some raw assets and data, we have managed to set up some services for anomaly detection, some short-term forecasts. In this case, it is for some wind power farms. And these allow us to connect SMEs with the end users. In this case, it's PPC, who owns the wind power farms, and to enable this AI-based experimentation. And here you can see how this forecast can become operational flexibility. So we have different prices, signals. We have the electric vehicle, the total baseline, and we aim to propose scenarios in order to manage these flexible loads in an optimal fashion. In the case of the high voltage, you can see some examples. Here we experiment with the IEEE 39 bus topology. So we demonstrate how we can better optimize this topology and provide scenarios for stability like N-1 and contingency analysis scenarios. And the next step is, of course, to work on it with our real TSO in this project, which is LS from Slovenia. On the other hand, you can see some related services for the distribution grid. So this is a voltage estimation case. The error distribution is seen in the middle of the slide. And we have also made available a digital twin of the whole distribution system operator topology via our digital platform. Finally, you can see here some of the cases with regards to the buildings. So some buildings of the city of Athens have been available for monitoring, and even we have provided some day ahead, 24-hour ahead power consumption forecast. And with regards to our satellites, our smallest nodes, here you can see some pre-processing of the data that we have received from the hydrogen side. Here you can see some cases which span around the district heating network that is available in Spain. And at the left of the slide, you can see also some pipelines that have been developed for industrial flexibility. And one step further, these heating optimization algorithms that we talked about, they are in their first stage of implementation. We have developed some LSTM methodologies, and we have provided thus a forecast plus optimization real-time case for a day-ahead operation of the district heating network. So 8 services have been produced so far, one per different node. They are summarized in this slide, and I discussed upon them in the previous ones. And I think this summarizes the whole presentation. But before giving the floor back to Professor Chikridis, I would like to guide you through the platform, which has been developed with the kind support and lead of European Dynamics, and of course, with the active contribution from all the players of the consortium. This is a very good collaborative effort, and I would like to thank all the consortium for that. So here is the platform. This is a marketplace-like platform which aims to bring together partners like SMEs, like different asset owners and different end users like big DSOs and TSOs. I will make an example sign-in, so it's a single sign-on. So I'm signing in as an SME now, as Dan, for example. So if I can enter this platform, I can see the whole possibilities that are available here. And actually, when I enter this page, which is the marketplace, I can see all the services that are available. So you can see 43 services found here, already onboarded. For example, I can enter one of those. So this could be, for example, building energy consumption forecasting. And once I enter, I see the description of what the end user needs from me as a startup, all the requirements needed, and who is the provider of the assets. So I can see a similar picture of all these things, and in the next version, which will be available in a couple of weeks, I will also have the chance to download the 5-page PDF per service to understand the whole needs. Then I can also enter this page and find the partners to manage with. So I can see which end users have been drafted, have been assigned. I can click on them, find which is the contact person here. So I can already send an email. I can visit their website. I can understand what they need. I can even open their organization profile and even contact them via the marketplace. And then here are the assets. So what is available there? Let's say that I want to develop a service around buildings and photovoltaics. Then I can see what is available. I can search. So, for example, I would put here what I need in terms of categories. Let's say that we need some digital twins. So I click it. I see that there's a digital twin of the whole building stock of Athens. So I can even click on it. And here is a summary, a description of the asset. And again, I can go to the related resources. So I can click on that, which takes me directly to the asset. I can see the whole buildings. I can view the map. So everything is in place, and the data sets can be even exchanged in a very secure fashion via the whole data space principle. Going one step back, I can even check for other resources. So if, for example, at this moment, I'm not interested in buildings, but I'm interested in, let's say, renewables, I enter this hydroelectric power plants dashboard. Again, a description, the service overview. And again, I'm transferred to the decentralized platform. Here is, for example, the resgrids.enertef.epu into UAGR, which has all the data for the hydropower parks. So I can download them. I can start negotiating with the end user. I can see some dashboards with their inflow analysis, their water production, some indicative analysis of water balance, things like this. I can negotiate with the end user via contact him via the EnerTEF portal directly, and we can start this negotiation, this request, so that we can start collaborating. And this is how, in a nutshell, we bring the whole environment and ecosystem of SMEs and startups together with the end users. Thank you very much.
Thank you, Elissaios, for the presentation. We're only 11 minutes late, which is okay. Maybe we can take some extra time at 12:30 to complete the discussions, because these topics and these projects are really, really interesting. If I may take a moment or two, I had a number of slides to present, but I'm going to focus on 2 or 3 of them. Let me make a general observation that what we see today is an arms race, and this arms race is based on AI-empowered software. What was a lethal weapon in the 11th century, the crossbow, or nuclear technology in the 20th century, this is a role played by AI today. And I'm a bit concerned in my European conscience, because it seems that Europe is not the leading player worldwide. The United States and China are playing a more significant role, and Europe is somehow left behind. So in my opinion, I think there should be more funding by the European Union on AI-empowered software and AI-empowered systems. And I think the European Union should aim towards autonomy, technological autonomy in the AI sector and in the applications of AI in various areas, including energy. What AI is actually doing today is, is the following. Back in the 20th century, in the last decades of the 20th century, I was an undergraduate student back then. What we saw was the digital revolution. In other words, computers of that era allowed us to simulate systems and essentially to forecast the outcome of experiments. In the first 2 decades of this century, we observed the collection of huge and diverse data sets, and also we developed analytical, or if you will, classifier AI tools to process these data sets. What we have been seeing over the past 5 years is the emergence of generative AI, that is, that part of AI that produces synthetic data sets. And this comes with very many challenges and very many risks. And some of these need to be addressed by researchers and academicians such as yourselves. These challenges include the integration of human experience, domain knowledge, and artificial intelligence into the interaction schemes among humans and one or several AI agents. Challenges include personalization or individualization of software, that is, the development of software and systems that are oriented towards a specific individual or a specific group of individuals. Software and systems need to be dynamic in order to address the complexity of limited and biased data. Also, explainability, trustworthiness, and reliability are very important issues, as is the alignment of software and systems with human values. And one final remark is that we need new software engineering and systems engineering methodologies, and we also need new holistic evaluation of these pieces of software and these new systems, because traditional methodologies are not really sufficient to evaluate them. In fact, as we were discussing with Kostis Daskalakis from MIT about 20 days ago, we don't really know at this moment how to evaluate this AI-empowered software and these AI-empowered systems. So some of these issues we may be able to address today, and some other of these issues may be food for thought for future projects that could be funded by the European Union. I have here several questions that Tudor posed, and they are actually very good questions for everyone in the panel. First question is, what criteria determine whether an AI pilot should move into production? Would any one of the panelists like to respond to this? Vangelis has raised his hands.
Yes,
Vangelis?
of course. Thank you, George. Yeah, this is a great question, because this is something we are trying to answer from day one of EnergyGuard project. So in our case, our platform works as a consultant, let's say, as an advisor. So we will not say that now you cannot enter production, but our tools like trustworthiness assessment, compliance assessment, etc., will give a very high risk profile. So on the one hand, the company still can release the product as production product, but there will be reports that say that you are not very compliant in these aspects, let's say.
Great. Thank you, Vangeli. Another question again by Tudor. Am I pronouncing it correctly, your name,
it's
Tudor?
okay.
Okay.
Yeah, perfect.
How is data quality assessed for AI in energy operations?
I think the following two questions should be treated together. So
Okay, how is missing data handled?
In most of the services that have been provided, to me at least, the assumption was that the data is there. But usually, or some of the time, the data is not there or is not available. Some stakeholders don't want to make that data available. So I don't know if this is handled somehow in the projects.
Okay, maybe Vangeli, maybe you should allow Johanna to answer this, and then we can come back to you if it's all right. Johanna?
Yes, yeah, so we actually have designed specific services to actually target that to provide complete data sets. So on the one hand, we actually have so the data that we provide is then sometimes aggregated to a level so that we do not face any GDPR issues anymore, which then could be the case if we have a distribution grid data, for example. But then we're also looking into this data synthesization and augmentation to actually fill the gaps of missing data. But that is then for some of the specific applications. And I didn't show that because we have the 4 nodes, so we have a lot of different applications that we actually do this for. But yeah, that is one of the problems and challenges that we're also addressing with our data provision part of the services.
Yeah,
that's
thank
really
you.
Interesting, but I have one follow-up question. Did anybody try to
Tudor,
use?
maybe
Yeah.
we should allow Stefan to
Okay.
answer this question as well. He has raised his hand.
Hi, yeah, maybe I can also jump in. So coming from a vendor
Yes,
side,
please. Yes, please.
this often looks a bit different. And usually if you start, I don't know, constructing a model for a certain problem or for a certain use case, there is tons of data out there, like the research academic one, which is very good to develop. But I think, as everybody knows, real world data is nowhere close to that academic research data because, I don't know, messy formats, gaps, time zone mismatches, anything can happen, and that's the easy ones you get. I think what also would be nice from a vendor kind of thing is like if you can pull from a TEF cleaned up data set, so to say, like where everything is in place, so you can start developing on real world data, which is cleaned already, but also get the chance to get the raw data. Then you see like, okay, there is mismatches, there is gaps, so you get also familiar with how you usually would get this data, because we have seen quite a lot of things already in all sorts of aspects, basically. So I think that would be a very nice thing for AI vendors to have 2 versions, like raw and already cleaned data.
Great, thank you. Anyone else who would like to answer these questions, or Stratis, please?
Yes, from a slightly different perspective, I think the answer depends also on the business use case. What are we talking about? Is it about, just to put it in simple terms, forecasting? Is it about control? Is it about decision making? What are the implications when we don't have the actual data that we need? There is a totally different approach depending on the impact, for example, of what we are doing. I think this is a very important question we need to answer before we move to the specific techniques and how we handle the missing data, which is, of course, a very important and serious issue. But I think it's a matter of strategy. What kind of problems do we solve and how do we solve them? So I think the starting point is the business use case. And I think with regards to what you have mentioned before, what kind of apps and the leadership that we need to take as Europe is also relevant to this actual business problem. We need to actually close the loop between the methodologies, the business, and how we drive the market towards a specific direction. And I think this comes, if we look at the big picture, from the fact that we are moving from a centralized energy system to a decentralized energy system that needs to be smart, that needs to be autonomous, but also needs to fulfill certain constraints that are relevant to the grid. So I think we need to answer these questions, but definitely there are different techniques that can be utilized to these ends.
Okay, I think, thank you, Strati. I think Vangelis also wanted to add something, add a comment.
Yeah, regarding EnergyGuard, we have a twofold approach. So, for instance, for SMEs that do not intend to share their data, they want to keep it private. We don't intervene at all at their data, and we have no access to that. But if we talk about services that are published to our platform and data sets that are published to our platform or through data spaces, in order to publish this data, we have specific common data models. We have several data anonymization tools in order to fulfill GDPR requirements. And of course, we provide the tools, but the responsibility of cleaning the data is on the user. We provide tools for data anonymization, for data cleaning, data imputation, and they can use these tools. And after that, we review the data sets, the service that are going to be published, and if they fulfill our requirements, they are indeed published in EnergyGuard.
Okay, Tudor, you posed the question. Let us know your thoughts on the question itself.
I have only. It's difficult to manage this, and I'm pretty aware of these aspects. So, but I'm thinking about the follow-up. Maybe one of the services could be a data generation service that could leverage some sort of large or small language models, some constraints of the service provider, of the data provider, and to generate some samples in order to allow the testing of the models. Maybe that could be a nice service or a nice investigation.
This is where
I would say
generative AI comes into the picture.
I think the idea posed by Tudor is in the correct direction. Sometimes not all datasets could be available for security reasons, especially in high-risk critical energy applications. These are the first that are affected in emergency situations, as we've seen with the recent wars. So this pinpoints to a new field in academic research, which is synthetic data generation. And I know this question of Tudor is in the correct direction. We have been working together in some other project on that. And sometimes it's easier when it comes to time series that have certain temporal patterns. Some other times it can be quite tricky when it comes to graphs and topologies that are very complex and difficult to understand. And what we should have in mind is that the new synthetic datasets should always be evaluated before used, and they should comply to the laws of physics, because at the end of the day, when you generate some data, then all of this should, for example, in the energy domain, be compliant to the laws of Kirchhoff, which are the first ones that we learned about. Otherwise, these new data that are generated cannot be credibly used, and perhaps the rule of garbage in, garbage out will be applied, and we will not have had the chance to do something realistic.
Thank you, Elissaios. We can move from the questions on the data to questions on the models, if you agree. In other words, the development of models is not easy, it is not inexpensive, and it is also energy consuming. So what can we do about this? In other words, can we transfer models from one area to another area? What are the challenges associated with such an approach? Let me just mention that in order to develop a foundation model for the energy sector, they have estimated that the amount of energy to be consumed equals the electricity consumed by 5 electric cars in a period of 10 years. So it's not something that we can neglect. This is a factor that we need to take into account. And therefore, if we can transfer models and services from other areas, this would be good. Any thoughts on this? How easy, in other words, will it be to transfer existing models to the energy sector? I think Vangeli, in previous works, this has been addressed to some extent. I've seen relevant papers published. Maybe, Vangeli, you can tell us more about it?
Yeah, we have done several efforts in the past. It is not that easy to get a model and make it working well for another facility. And along with EnerTEF Project, we are working on a foundation model, pan-European foundation model. Towards this direction, of course, we are in the beginning of this process. Yeah, we are looking forward to see some great results on that. Probably Elissaios can also say more about that.
Yes, thanks, Vangelis, for giving me the floor. Indeed, it is a collaborative effort of the whole academic industry society across 32 countries in the EU, 50 plus partners, working on collecting a critical mass of data so that we can manage to train a European scale foundation for model for the electrical grids. And more details on that will follow. I know that Professor Tsihridis is organizing a very nice workshop at the beginning of July where we will have the chance to present more details about this model and the first actual results. Thank you.
And the papers are actually very, very good. The papers to be presented, 20 or 21, if I remember correctly, plus a keynote speech. They are all very of very high quality and very impressive works. Okay, another question is has to do with adversarial attacks. How are these AI models tested against them?
Yeah, this is more for EnergyGuard, I think, this question.
Okay, Vangeli, I hope you're not tired answering questions. So please,
with you, never.
Please enlighten us.
All right. So yeah, we are focusing a lot on data input manipulation. So we try to automate the process as much as possible. So the user provides their model, provides several configuration and the data set in which their data were trained. And yeah, we apply several perturbations in the input data in order to, let's say, find the most influential factors, the most influential features, let's say, that could manipulate the output data. This is the current approach we follow. And this has helped us a lot in hardening some of our AI models.
Okay, thank you, Vangeli. Any additional comments on this? Or should we move to another question? Okay, another question has to do with impact and performance evaluation. I think we somehow touched it a bit a few minutes ago. So let us come back to it. How do we measure impact and how do we measure performance after deployment? In other words, we developed an AI-empowered system for the energy sector. How are we going to measure how well it performs, and how are we going to measure how impactful it is on citizens' lives?
Yes, I think there are two aspects. Maybe economical perspective or also human perspective. Does it replace humans? Do we gain more jobs? Do we lose jobs? It's a trade-off. So it needs to be somehow, I think, discussed and assessed.
And also, do we need to maybe retrain people on using the system or retrain people on developing such systems? And in my mind, this is my personal opinion, of course. At the moment, we cannot exclude humans. We need to keep them in the loop, and we also need to employ AI scientists and AI engineers when we develop these AI-empowered systems, because otherwise we may misuse or incorrectly use AI technologies. Yes, Stefan, please.
When I can continue there, I think so human in the loop is very important factor. So what we have seen is you need the trust of the people. So I don't know, for example, if you have a congestion management tool for the operation room, the operators need to trust what is suggested there. You need to show them that this is a helpful thing. This is not replacing them. So you need to, I don't know, build up confidence on their side. But I think there is a very sharp edge, a challenge. So don't build up too much confidence so that operators still stay critical. Like I don't know, the AI tool suggested 100 times the right topology, for example. So they just blindly trust it. That should not be the case. So I think on the one hand side, you need confidence from the operator, for example, but they still need to look at this critical and say like, okay, this is a good one. Or if they are not sure, they should be able to see what's the impact of, for example, a suggestion on a topology change or such things.
In my personal opinion, I think you're absolutely right, Stefan. We should not address these issues with phobia, technophobia, but we should also not overtrust them. We should be somewhere in between these two extremes and, use the technology, but also evaluate it ourselves. I think Stratis raised his hand. Stratis?
Yes.
And then
I mean, based on a recent study, I don't remember, I think from MIT, around 95% of Gen AI projects don't move from the pilot phase to the real implementation phase. And The reason for this is that you may have developed a very nice AI tool, it has been validated, blah, 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 all these kind of things. But then you go to the managers and they don't trust it because they cannot implement it in an existing workflow, in an existing system. So we must take into consideration that AI or the AI tool or the AI solution is just a small piece in a very big chain. And I think this is where humans, just to answer this question, can have a very important role. How do we take this AI tool and how do we implement it in an existing workflow? And then with regards to the impact, of course, it's a very good question, but let's say from my side, what I would like to highlight is the following, that in this energy system where we don't have any more where we have a democratized, let's say, participation. We have a lot of people that have photovoltaics on their roofs and they can participate, they can consume their own energy, they can sell the energy and so on. This brings a big problem with it, that these people don't have necessarily the technical or the digital expertise on how to become part of this system. I think European projects like ours can help in this direction. We can develop tools that can be open source, that can be utilized, let's say, by small consumers, by citizens that have a photovoltaic on the roof, and we can bring this intelligence in a plug-and-play solution, in plug-and-play manner, so that they can utilize it and become part of this energy system. Because in order for this transition to become successful, you need to have massive, let's say, participation from end users that don't have this technical and digital or AI expertise. So I think for us as European projects, we could have a role there. We could offer these solutions. They can be tested. They can undergo all this kind of systematic investigation in order to offer it to them. Just to have an impact, let's say, from a European project point of view as well.
Thank you, Strati. And I think Tudor wants to add something.
Yes, my main concern lately is not that AI will replace humans, but the fact that humans will eliminate them from the loop. Because I noticed even on students, they have more trust in the output of the AI than in themselves or on the feedback of the human. So maybe the new generations that will learn with AI will not be that confident in reviewing the output of the AI.
This is actually a concern. I'm actually speaking as an AI person, but I'm taking the role of the, devil's advocate. This is a concern that has to do with every application of AI and every AI-empowered system. With Elissaios and Professor Marinakis and other colleagues, we published last year a couple of conference papers on trusting AI applications in energy. And it is true that some people over-trust it. And we need to realize that these AI systems do not necessarily provide the correct answer. They only provide the most probable answer. And there's an interesting example. If you ask ChatGPT or some other similar system, where is the filter in my refrigerator? It will say in the upper right corner. But there are models, refrigerator models, for which the filter is elsewhere. And they will give the same answer, upright corner, even though it is not a correct one. And speaking of applications in energy, last year with my wife, we tested ChatGPT. We asked it about renovation and energy efficiency and so on. And it gave us some ideas. And then I asked for bibliography. And it produced synthetic bibliographic data, non-existent papers, in other words. it said some of the recent works are the following, and some of those did not really exist. And I said, but they are not existent. They don't exist. They said, yeah, but based on the previous records of these authors, they could have published these works. You know, we need to be very careful about AI, and this is an issue of research, actually, trust in AI. And this is an issue that needs further funding in order to be properly addressed. All right, I think we are on time. Should we go ahead with other questions? Are you happy with the discussion we had so far?
Me personally, I'm happy.
Yes,
It
and I
was a
think
nice
we're
discussion.
already 3 times overdue, so we could conclude, I think.
Yeah.
Okay. There are so many questions to be asked that we don't really have. I mean, we would need several hours, just an hour and a half for those. I think we had a good discussion. I think some of the conclusions include the following. We need to keep humans in the loop, support humans, not replace humans. We need AI experts and AI engineers to participate in the development of AI-empowered software and systems. And there is a very eloquent phrase by Eliezer Yudkowsky. By far the greatest danger of AI is that people conclude too early that they understand it. And we need to develop new holistic evaluation approaches for these systems and not just rely on the traditional verification or validation approaches. And this last thing is an open research issue. We don't really know at the moment how to correctly and to fully evaluate AI-empowered software and AI-empowered systems. And we hope that the European Union will continue to fund such projects in the future and maybe even increase the relevant funding. Well, thank you all very much. Unless there are additional comments, maybe we can conclude this webinar here.
Thank you for the moderation,
Thank you.
Professor Sigridis.
Thank you all. Thank you, Carly,
Bye.
for
Bye.
managing this webinar. Thank you for your participation and very insightful ideas. And good luck in your endeavors in this research area. Thank you.
Thank you.
Bye-bye.
Bye-bye.
Thank
Thank
you.
you. Bye-bye.
Bye.
Bye.
Thank you. Bye bye.